Models of cells, like this one, are extremely useful. Look at all the different cell parts, or organelles, that you can see in one small diagram. However, there are some limitations. First, do you think all cells look just like this one? Here's a different model of a cell. Does it look the same as the previous one? Even the shape seems to be slightly different. There are also some parts in this one that aren't in the other cell model. Even if the shapes are similar between models, you might be able to spot key differences. To answer the question, there are some limitations of this model. First, it's a drawing of a real-life object, a cell, and the artist may use colors for different organelles, which could vary from model to model, or not necessarily be accurate if you were to look at a real cell under a microscope. Other objects are enhanced in texture and shape so that you can really understand what's going on. But in real life, you wouldn't even be able to see some of these objects even with a microscope. We've also seen cells come in different shapes with different numbers and locations of organelles and even different organelles altogether. The bottom line is, there's no one model that can capture the wide variety of cells that exist in the real world. Let's take a look at our second model of the solar system. What are some key limitations that you notice in this model? Here is a different diagram type model, also of the solar system. Notice any key differences? A really important thing to consider when you're looking at a model like this is that the sizes of the objects that we're talking about, the planets and the sun, are enormous, as well as the distances between them. So for any one model to properly capture everything just right is highly unlikely. Getting back to the question you were asked about this model, the first thing to notice is the size of the sun. Do you think it's big enough? In reality, 1.3 million Earths could fit inside our actual sun. Do you think that 1.3 million of the little blue Earth models could fit inside the yellow sun model? Hopefully the answer is clear. The next thing to look at in our solar system model is the sizes of the planets compared to each other. Mars, Earth, Venus, and Mercury are all about the same size in the model, but in reality, Mercury and Mars are much smaller than Earth. And comparing Jupiter and Saturn to the inner planets, there's some inaccuracy as well. As a matter of fact, 1,300 Earths could fit inside Jupiter. Does it look like 1,300 Earths in this model could fit inside the model of Jupiter? Hopefully you're seeing some of the inaccuracy. The last things to think about in our solar system model are the distances between the objects themselves. Mars, Earth, Venus, and Mercury are all fairly close to each other and fairly close to the Sun in reality, and this model does show that. Also, Jupiter is pretty far away from Mars and all the other inner planets, which this model also shows. When you look at Saturn, Uranus, and Neptune and where they're supposed to be, they wouldn't even fit on this screen. And, as a matter of fact, they may not even fit in the room you're sitting in because they are just so far away from each other and so far away from the Sun. So this model does give us some good information about our solar system, but does have some limitations, mostly due to the gigantic sizes of the objects it's trying to show us, as well as the enormous distances between them, and it's impossible for any one model to do that just right.